this video, we're going to build a simple calculator in Python. The real value in the video though is seeing how you can go from a scary blank page to a fully working script that does exactly what you want it to do. Before coding a single line, I'm going to write out simply and plainly what my requirements are. Requirements are a super important part of coding. Even if you're the only user, being clear on your requirements can save you a lot of headache. I'm going to write these requirements in the form of bullet points from the point of view of a user of this script. For this calculator then, I want to be able to enter two numbers. I want to be able to choose an operation. For this example, I'll restrict it to 4 operations: addition, subtraction, multiplication, and division. Then I want to see the result of the operation. And finally, I want to be able to end the program or continue with another calculation. Right, now I can start coding. To start off, I'm going to ignore all the user input stuff for now and simply put in place the basic logical flow my program will follow. I'll declare 3 variables. A and B will be the input numbers, and then result will be the result of the operation. In this case, I've hard-coded A and B as 40 and 34, and the operation as addition. Next, I'll use a print statement to print the result for the user. F strings are really useful here because we can put the result variable right there in the string. Alright, let's run this program as it stands. All it does is perform the addition and print the result to the screen. As an aside, the variables we set are integers, but we can set them as floating point variables as well if we want, by just adding a decimal point like so. Let's tackle the next part of the program. I want the script to take user inputs. For this, I'll use the function input to prompt the user for a value. All this line does is ask the user to enter a value and set that equal to A. Here's a problem. The interpreter is complaining that it can't add a string and a number. Let's fix this by casting the user inputted value for A as a float. There. Let's try it now. That's better, and it works. I'll do the same now for B. Now, the script can take 2 numbers from the user and add them together. That's the first requirement satisfied. The next thing we need to do is support the different operations that we specified before. At the moment, addition is hard-coded, so our script won't do anything else but add the 2 numbers together. I'll change this up a bit so we have a variable which holds the operation choice. I'll then create an if statement that checks the value of the operation choice variable. If it is equal to add, then result is calculated appropriately. Let's run this to see where we are. Now, what if I want to subtract the numbers? One way of supporting more operations is adding more if statements. I'll just add another if statement here for subtract. But this is a little untidy, so we can improve things by adding an else if statement underneath our if statement. I'll add else if statements for subtract and the remaining operations we need to support, which are multiplication and division. Let's run this now. I forgot to prompt the user for what operation they want. So that operation variable is still hard-coded. Okay, let's use the input function to ask the user what operation they want to perform. Now when we run the script, everything works as expected. Great, there's still a problem though. Every time we want to run a new calculation, we need to execute the script again from the terminal. We can address this with a loop. We'll use a while loop that will keep running our code as long as the condition we give to it remains true. In this example, I'll just keep looping forever. While true simply means as long as true is equal to true, the loop continues. And true is always going to be equal to true, so this will continue forever. Let's try it out. There, that keeps running now for as long as we want. Let's go back to the requirements to see how we're doing. We can choose an operation, we can print the result to the screen, and we can now end the program or continue. Or kind of, anyway. Did you notice that to exit the program I had to force it to stop with a keyboard interrupt? That is, I pressed Ctrl followed by C. This isn't very tidy and we don't really want our user to have to do this. Okay, let's fix this by prompting the user for a decision. We'll ask them if they want to continue or quit the program. If they enter Q for quit, then we'll break out of the loop and the program will end. On the other hand, if they enter C, then we'll just use pass to continue on with the loop. Let's try this now. Alright, everything's looking good. The last requirement is now done. We now have a calculator script that meets all the requirements we set out at the start. We followed a really simple process to get here from nothing. First we created requirements. These were a bunch of bullet points of what we wanted the script to actually do. Next, we started off slowly and built up each bit of functionality step by step. With every step, we fleshed things out some more until we satisfied each requirement. This doesn't have to be the end either. We could have a version 2 of this script and define some new requirements to improve the user experience and feature set. What would you add to this? Leave a comment down below with your ideas. I hope you found this useful. Thanks for watching.
Oh, hello. My name is Steril.